everyone, I'm Molly, the island's education manager here on Martha's Vineyard with the Trustees. The Trustees is Massachusetts' largest conservation and preservation organization with 118 properties throughout the Commonwealth. For today's lesson, we will be studying sea level rise. Now this may be a term that you've heard before, or it may be completely new to you, and that's okay. So for this introductory lesson, we want to know what is causing the sea level to rise and how is it rising. This lesson is designed for grades 3 through 8. Now to follow along with me today, you will need to gather the following materials. You will need 2 food storage containers. So I have 2 glass food Tupperwares. They don't have to be very big, but you want them to be the same size. So 2 of those. You'll also need 2 pretty good chunks of Play-Doh. So I have a couple colors combined here, but about the size of an adult hand. You'll need 2 of those. Then you want some ice. So I just have my ice in a jar, in a bowl here, but you can use ice from an ice tray as well. So a good amount of ice, at least from 1 tray. You'll need a pitcher full of water, or a glass full of water that you can refill. You'll also want to gather a pencil and a marker, a ruler, and check on your ruler to make sure it says millimeters, so mm for millimeters, and you're looking for the little lines that are very close together. So my ruler has centimeters labeled and there's little lines that show millimeters, and we'll look at that closely in a bit. So a ruler with millimeters and then a piece of paper. So make sure you have all of those materials together, and then you'll be able to complete our fun activity along with me today. To start with, let's answer our first question. What is causing the sea level to rise on a worldwide scale? So simply, when we humans burn fossil fuels like coal, oil, and gas, an excess, so a greater amount of carbon dioxide, is released into the atmosphere. This carbon dioxide in the atmosphere acts like a heat-trapping blanket. As we burn more fossil fuels like coal, oil, and gas, we release more carbon dioxide, which in turn thickens that blanket around the Earth, trapping in more heat. So let's imagine for a moment adding blankets around your body. The more layers you add, the warmer you become. So when we think about the Earth, this then causes an increase in the Earth and ocean temperatures, which disrupts the climate. Warmer atmosphere and ocean temperatures cause land ice to melt. Also, an increase in ocean's temperature causes thermal expansion of the water. So as the water temperatures increase, water molecules in that water expand and they take up more space. This all results in a rising sea level across the entire globe. So today, in our hands-on activity, we are going to take a close look at land versus sea ice. And we'll understand what is land ice, what is sea ice, and what happens when the temperature increases due to humans burning fossil fuels. So let's get ready for our activity. So gather your materials. You can pause the video, gather your materials, and we'll come back together to start doing our fun activity. Okay, so I'm now all set up to start the activity. I have my 2 Tupperwares and Play-Doh at the ready. So the first thing you're going to do is take some of your Play-Doh, and this is going to be your land. So you're going to put your Play-Doh into the Tupperware and make somewhat of a flat land mass just on one side of the Tupperware. You can work it down a little bit and just try to get it somewhat flat on the top. Okay, so I think that looks pretty good for my green one. And now for this light orange one, I'll do the same exact thing. And you can follow right along with me in this process. And again, I'm trying to get it somewhat flat there on the top and about at the same level as my green Play-Doh as well. And again, it takes up about half the bin. Okay, so now we have both of our bins set up, and I've made some labels for us. We have one label that says floating ice and another that says ice on land. So this bin with the green, we will have our ice on land in this bin, and I'll explain that more in a moment. And then this one will be our floating ice. So I've labeled it just so we'll remember which is which as we continue with the activity. So now we're going to place our ice cubes in each bin. But we want to look closely at our labels. So this ice on land, this is the land ice that I mentioned earlier. So you're going to take your cubes of ice and fit as many as you can on your land. So I have 2, and try to make sure your ice chunks are about the same size. 3, 4, 5. Looks like 5, oh, that one's a little bit smaller. Get one about the same. So it looks like 5 will fit up on land for me, on my ice on land. And then your floating ice, you're going to put the same number of ice cubes in the bottom of your bin. So again, look for this about the same size as the other ones, and we're doing 5. Whoops. So 1, 2, 3, 4, one the same size, 5. Okay, so at this point, your bin should look just like mine, with ice on land there, and then floating ice. Great. Now what we're going to do next is take our pitcher of water and pour the same amount of water into each bin. So it's very important that you make sure you pour the same amount. And what I'm going to do, and what you should do as well, we'll start by pouring into this bin with our ice on land, and you're going to bring the water up to the land, but you want to make sure it's not touching the ice. Okay, so I'll start with ice on land, and we'll slowly pour it in. So it comes up, but it's not going to disturb those ice cubes. So that looks pretty good. So we're imagining that this is our land ice here that's out in the ocean on an island. So there's land and then an ice sheet on top of that land, or a glacier, and then there's the ocean. So now we're going to do the same exact thing over here. Now I'm going to make sure, is it about the same level? This needs to come up a little bit more. Yep, a little bit more, and what I'll do next is measure it with my ruler. So I mentioned earlier to grab a ruler. Okay, so this ruler shows centimeters and millimeters. You see the mm and the cm. So you want a ruler that shows that as well. You'll see it says 1, 2, 3, 4, 5, 6. Then there are 10 lines here because there's 10 millimeters in 1 centimeter. So we are going to measure our water level, and you can do this to make sure your water level is the same. So my water level is 3.5 centimeters on the left side there, and this one is 3.5 centimeters. So you can just do that to confirm that you have the same amount of water in each. Okay, so next you're going to take your marker, and just for a visual aid, draw a little line on the side of your bin where that water level is on each bin. So I know each one is 3.5 centimeters, but I also have that visual aid now to look at as well. Next, we're going to get our results sheet together. But before we do that, I want you to think about what is going to happen. What is your prediction as to what will happen to the water level on this side in this bin versus this bin? So our ice on land and our floating ice bin. Will the sea level rise the same amount in each bin? So think about that for a little bit. And then, with your piece of paper, you're going to copy my results sheet here. So, you want to have your time in minutes, 15, 30, 45, 60. And then water height, because we're going to continue to measure our water height in millimeters or centimeters of floating ice and ice on land. So you can pause your screen and copy that onto your piece of paper. Now I'll take note of the time. So when we started this, it's about 11:55. And each bin was even at 3.5 centimeters or 35 millimeters. So now we're going to wait 15 minutes and we'll re-measure the water level in another 15 minutes. Okay, so the first 15 minutes have passed, so I'm ready to take my first reading. Now I'm going to line up my ruler on the side of my bin, and I'm seeing it's almost at 4 centimeters. It's a little bit below. It looks like it's at 38 millimeters. So the reading I'm getting here was just 2 lines below the 4. So 10, 20, 30, and then these 8 little lines here for 38 millimeters. So I'm going to write on my sheet the ice on land. Because remember what bin you have. Make sure you put it in the right spot. This ice on land will now say 38 millimeters after 15 minutes. Let's do the same thing for the floating ice. Line up my ruler again. And it looks like still at 35 millimeters. So in the floating ice section, I'll write 35 millimeters. Okay, so now we'll wait another 15 minutes, so that 30 minutes will have passed, and we'll do our next reading. Okay, so now another 15 minutes have passed, so 30 minutes in all since our initial measurement, and we've taken a measurement at 15 minutes, so this is our 30-minute measurement that we're looking to fill in now. So let's start with our ice on land. I'll take my ruler, and again, as best as I can, look to see what level that water is now at. It looks to be almost exactly 4 centimeters or 40 millimeters. So right here at the 4, which is 10, 20, 30, 40 millimeters. So ice on land is 40 millimeters. I'll write that down under 30 minutes. 30 minutes has elapsed in total. And now I'll do the same thing for floating ice. And it looks like it's still at 35 millimeters. So floating ice after 30 minutes is 35 millimeters. Okay, now we will wait another 15 minutes, so we'll be at 45 minutes total to take our next reading. Okay, another 15 minutes has passed, so 45 minutes in total. We're going to take those same measurements again. So first for our ice on land, and I can even see visually where my visual aid marker, the water is definitely above that. So now it looks like it's about 41, oh, that is bad, 41 or 42 millimeters. Looks like 41 millimeters. So I'll write that on my sheet, ice on land. After another 15 minutes is 41 millimeters. And we'll do the same thing for the floating ice. And even I can see my mark, this water level hasn't changed. It's still 35 millimeters. And the ice here in this bin has almost all the way melted. This one is slowly still melting. Still some big chunks of it there on land. So still 35 millimeters for our floating ice. Okay, so we have one more reading to do, our 60-minute reading, which will take in another 15 minutes. Okay, we're ready for our final measurement after 60 minutes total, but another 15 minutes has passed. So for ice on land, I'll take my ruler again. It looks like it's about 42 millimeters. So ice on land, 42 millimeters. And then floating ice. Again, I can even use my visual guide, that line. This is still at 35 millimeters, right at that same line from the beginning. So make sure you jot down your measurements on your sheet, and we can take a look at it closely. So we can see clearly floating ice remained the same after 60 minutes at 35 millimeters, the sea level. And then the ice on land went from 38 up to 42 millimeters after 60 minutes. Now your numbers may be different from mine depending on your water height to begin with and the temperature of your water, if your ice cubes melted faster, or maybe even your house was a little bit warmer than mine. But we can even see visually in our bins the ice on land. has melted. Remember, we had 5 cubes up here. I can see barely a little one there, 3 there, and then we're missing the 5th one has melted completely. All of the floating ice has melted, but as we know from our water height, that water level hasn't changed. You can see this land up here is still dry, while this land over here is wet. So the water has risen there from the ice on land melting. So how do these results compare with your earlier predictions? Which bin did you predict would change the most with water height or the sea level? Now, when we look at our results, why do you think this happened? So when the ice cubes on the Play-Doh melted, the water ran off and added to the volume of water in our bin or in the ocean. Now on the other side, the floating ice, those ice cubes were already taking up space in our ocean. So even when that ice melted, the water from the melted ice just fills that existing space that the actual cube was still taking up. So that's why we're seeing an increase in the sea level from the melting land ice versus floating ice. As this floating ice melts, it's not increasing the sea level. So, as I said earlier, melting land ice is a contributing factor to the sea level rising. As we burn more fossil fuels, more land ice will continue to melt. It's important for us all to do our part to reduce and rethink our use of fossil fuels. So thank you for joining me today. I hope that you enjoyed this introductory lesson on sea level rise. If you're interested in more activities just like this one and other lessons, you can find them at our trustees website, thetrustees.org/at-home. Also, check out our YouTube channel where we have a full playlist of all the lessons that you can view that are similar to this one. I also encourage you to become a member of the trustees or renew your membership at this time. You can do so by simply going to thetrustees.org/join us. I look forward to seeing you next time.